Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and from last class we are discussing on concept of phases, and in this class also we will continue our discussion on phases and its application in different aspects, particularly in the interpretation of depositional environment. As in the last class we have seen that phases is a very important component in any sedimentological work, particularly when we are concerned about the interpretation of the depositional environments. So, in this class we will try to understand what we actually do in phases analysis, how we apply this concept of phases in phases analysis and how we apply this in the overall interpretation of sedimentary environments. As already we have discussed that a particular phases always indicates a particular depositional process, a particular process during the deposition of sediments. It does not indicate an entire environment. To understand the entire environment, we require many other phases together which are lying in the adjacent areas in that particular area, in that particular basin, and they may occur horizontally, they may occur vertically. So, when we are talking about the overall depositional environment, whether it is in the recent or whether it is in the past, we have to look for all the phases types which are occurring in that particular area horizontally and vertically, that means spatially and temporally. And when we consider all these phases types together and we combine the depositional processes together, what we get or what we interpret is the overall distribution of the depositional environment, how the environment was occurring, what are the different processes in that particular environment, and how those environments were responsible for the final product, that is the sedimentary rocks. So, starting from phases to interpretation of the depositional environment, this entire process comes under the broad regime called as phases analysis. So, what we do under phases analysis in precise words, it is the interpretation of strata in terms of depositional processes and depositional environment. So, when we are talking about one phases, we are talking about or interpreting about the depositional process which is responsible for that particular phases. And when we are considering several phases, all the phases occurring in that area, we are talking about or interpreting about the depositional environment. So, it is about the interpretation of the rock strata. So, how can we do that? It is about the interpretation of the rocks based on the phases, and when we are defining the phases, we are considering different aspects or properties of the rock. So, each of these properties have certain significance in terms of its responsible processes. So, when we are looking into one phases, it is giving us idea about the responsible process, and we can combine them into a phases association, and those phases association give us idea about the sub-environments, which is nothing but the combination of several processes occurring in a particular area. So, definitely we have to rely heavily on the phases associations, because the phases associations give us idea about the genetically linked processes which is occurring in that particular sedimentary environment. Just think of any marine basin today. You have a coastal area followed by a shore part, followed by a shelf part, followed by the deep marine part. So, at today's time plane, everywhere we are getting some sedimentation as per the depositional processes going on in that particular area. So, definitely when I am talking about the coastal area, just for example coastal area, so in that coastal area, it is not about only one process, there are several processes going on altogether. There are some waves are coming in, some rip currents are forming, some longshore currents are forming, also some organic activities are going on, and some sediments are supplied by the river systems which are being distributed by these processes. So, definitely the products will not be one, there will be multiple products, that means there will be multiple phases. And when we combine all these phases together, we get a phases association, that is the coastal phases association in a very broad frame. So, that coastal phases association will be occurring in horizontal fashion, in horizontal distribution pattern on that particular time plane, that means today's time. Now, if I change the time plane, if I go to tomorrow, maybe after 1000 years, the time plane will change, and by the time the distribution of the environments will also change. So, maybe at that time the coastal area is now changed into a shelf area. So, definitely the phases types will be changed as the processes in the shelf area are completely different from the coastal area. So, what we will get over here a change in the vertical log. This already we have discussed in the Walder's law. This is the concept of Walder's law. So, when we are trying to understand a sedimentary environment, when we are trying to interpret sedimentary environment in terms of phases or through phases analysis, it is very important to understand or recognize phases associations horizontally as well as vertically, because that concept will give us idea about the distribution of different sub-environments within a sedimentary environment, both temporally and spatially. And then comes another aspect, the phases models. So, we try to compare this with some idealized models from individual depositional environments. Definitely, the processes going on in natural environment, say for example, today if you look at any environment, a river or a coastal area or a shelf, the conditions are not ideal. There are so many factors are there, but already we have some models prepared for us considering ideal conditions in each of these depositional environment. Those are called as phases models. This also we have discussed in our previous class. So, we can compare our model with respect to that particular phases model. Definitely there will be some deviations, and those deviations will lead us to think why these deviations are coming. So, when we try to get answer about that why that deviation, it makes our model unique, because that why that deviation, it is just because of some changes, some variations in the processes. So, whenever there is a change in the processes, deviation in the processes with respect to ideal condition, you will get some different phases. So, it is very important that we should compare at some stage when we have done this lateral correlation of different phases association and we are thinking of making the model. At that point, it is very important to compare with some idealized phases model of that particular depositional environment. And once that comparison is done and we are getting the deviation, based on that we finally come into the interpretation part where we recognize the sedimentary environments. So, these are some of the basic concepts that we always apply in phases analysis with an aim in our mind to interpret the depositional environment. So, what are the procedures, what are the step by step activities that we should do when we are going for this kind of phases analysis and from their interpretation of the depositional environment? The first step comes as the measurement of the section. So, it is irrespective of whether you are doing the field work in outcrop sections or you are looking at some subsurface sections, maybe from the data received from some well logs. So, first we have to measure the sections, and within this section we have to measure the thickness of individual phases types, and then comes the second component, second part, representing those phases types, and commonly we represent them through some graphic sedimentary log. So, graphic sedimentary log is one of the most important concept where we try to represent measured data, sedimentological strata, beds in vertical and lateral fashion through some pictorial method. So, it is very effective and very popular in sedimentology. So, we try to represent the phases types through construction of some graphic sedimentary log. We do that for all the sections available. Say for example, you have gone to the field work and there you are getting 10 outcrop sections. So, you have to prepare graphic sedimentary log from all these 10 sections, separate logs, and then we try to correlate them. We try to understand how laterally these individual phases types are continuing and how vertically they are continuing, how vertically they are repeating. So, we try to get idea about the regional associations, regional distributions through correlations across all these vertical sedimentary logs or graphic sedimentary logs. If you are working with the subsurface data, say for example, you are getting some gamma ray log, maybe you are getting some sonic log, you are getting some density log, the process is same, the steps are same. There we will go for correlation using some gamma ray signals, and there we will try to correlate how they are distributed, what is the nature of distribution of individual phases types, and the phases types are identified based on the variations in the signals. So, when we have done these comparisons and the correlations of different phases types, how they are occurring, how they are changing laterally and vertically, then we are ready to make the model. So, at that point comes the concept of phases model, and we have to compare our model with respect to the standard phases model. I can give you one example over here. Say in one area you are getting some facies types and you have prepared the graphic sedimentary log, and maybe based on the facies types, based on the primary sedimentary structures, it is appearing that it may be a tidal flat. So, at that point, if you are thinking of a tidal flat, we will try to compare our logs with the standard facies model of tidal flat. So, if your model is a tidal flat model, definitely it will have lot of match. If it is not, then there will be lot of deviations. Then you have to think of some other environmental conditions. So, this is the use of facies model, where we can straightway compare our model with respect to some standard model already prepared, already available for that particular sedimentary environment. And when that comparison is done, as I discussed earlier also, we go for the interpretation. So, this interpretation is about the entire depositional environment for that particular basin where you are working. So, that interpretation will include all the facies types, all the facies associations and how they are changing. So, it is about those portions of your log or model which are similar to the ideal facies model, as well as those portions which are not similar with respect to the ideal facies models. So, you have to interpret all these portions together and you have to give the final model for the sedimentary environment. So, this is how we do this facies analysis and how we apply this concept of facies analysis in the interpretation of depositional environment or sedimentary environment. So, as I told you here, this one very important aspect, the graphic sedimentary log. So, I think that it will be a good idea that we should have a very brief discussion on this concept of graphic sedimentary log, because so far in this course we have not introduced this particular term, and considering the broader interest, I would like to discuss that what we mean or how we prepare and represent sedimentary rock strata distribution of facies through graphic sedimentary log. So, what is a graphic sedimentary log? A graphic sedimentary log is a pictorial method or kind of graphical method for representing a series of beds or sediments or sedimentary rocks. So, basically we represent them in vertical fashion, how they are occurring in that particular section. That may be an outcrop section, that may be subsurface section. So, when we are getting one subsurface section or maybe one outcrop section, there we are getting those rocks occurring in vertical fashion, one above another. So, we just try to represent them in that way, how they are occurring in vertical order, considering the law of superposition that the bottommost one is the oldest one and the topmost one is the youngest one. If it is a deformed terrain, we have to apply our concept of structural geology. Maybe we have to unfold that terrain, we have to undeform that terrain, and then you have to reconstruct that which one is the oldest one and which is the youngest one. So, the objective of any graphic sedimentary log is to present the data in such a way that it becomes very easy to recognize and interpret the distribution of facies types and their occurrences spatially, temporally, and that we do using some symbols and certain abbreviations, certain textures, maybe certain colors, which can be easily understandable. There are some standard symbols available in textbooks which are also accepted across the globe. So, if you are using those symbols, you do not need to explain that what symbol you are giving, but you are allowed to use your own symbols, your own color or own texture, and in those cases it is a common practice that you should provide a key, a legend, that this symbol is representing this particular feature or this particular rock. Nowadays, we prepare this graphic sedimentary log using several softwares, and within these softwares already some textures are available, some colors are available which can be easily used, or you can prepare your own color, you can prepare your own texture or structure or pattern which can be used to represent certain features or certain properties of that particular rock. So, this is one example of how vertical sedimentary logs are prepared. I have just spent little bit of time over here to explain that how this kind of logs are prepared. So, this is one section where a vertical sedimentary log is prepared based on your observation. So, the first thing we have to plot over here is the scale. So, we start from 0 at the bottom, and as we move up, gradually the scale is increasing. That means the thickness of the beds are plotted over here. Remember, this is always done with older beds at the bottom and younger beds at the top. considering the law of superposition. So, when I am saying 0, thickness is 0, that means that is the start of sedimentation, and gradually the thickness is increasing, that means gradually the sediment layers are getting deposited. So, in this section definitely this part is the youngest one, this part is the oldest one. Now, here we have several columns shown. This is an ideal way of representing or preparing graphic sedimentary log, but in practice we can merge several of these columns. So, what we are getting over here, the first column is for representing the lithology, where using different patterns, texture or maybe color, we can represent the lithology of that particular facies. Say for example, this symbol is used for representing a brachia maybe, or maybe a conglomerate, and there you can see this much of thickness. So, it is representing the vertical thickness of that particular facies. So, maybe it is around half meter thick in this case. Then we are getting this symbol which is representing a sandstone. Here this stippled pattern texture is commonly used for representing sandstone. So, you are getting a sandstone unit, which is, if I just consider the lithology, it is starting from here, which is just below 1 meter and continuing more than 3 meter. So, the overall thickness is around 2.5 meter. So, in terms of lithology, we are getting a sandstone which is 2.5 meter thick. But now we can move to the next column, where we are getting a scale available over here, which is the grain size scale. For clastic rocks and for limestones, we have a separate scale. So, what is the meaning of this scale? Here we are starting from 0, this is the horizontal scale. It is starting from 0. We are plotting as per increasing grain size, clay, silt, sand with very fine, medium, coarse, very coarse. Then we have the granule, pebble, cobble, boulder. So, that means when I am saying about this conglomerate bed, it is plotted up to this particular boundary. That means if I try to redraw this one, it is covering up pebble size. That means this conglomerate bed is consisted of pebble size grains. Now, if you look at the top part of this conglomerate bed, there it is ending up at very coarse sand. So, that means within this bed the grain size is vertically changing, starting from pebble size grain to very coarse sand size grains. Now, if I look at this sandstone over here, we can see there is a change in grain size. So, in terms of grain size, now the sandstone can be divided into 3 parts. Number 1, this lower part where the grain size is very coarse, then this second part where the grain size is into the medium size sand, and then this third part where the grain size is further finer, maybe within the fine sand size range. So, when I am combining these two factors, grain size and the lithology, so now I am getting 3 different sandstones now. Initially this 2.5 meter thick sandstone, now it is getting divided into 3 different portions: a coarse grain sandstone, a medium grain sandstone and a fine grain sandstone. Along with that, some symbols are used over here, as you can see. So, these symbols are indicating certain primary structures, mostly the bed forms. So, this symbol, the first one over here, this one is used for representing the trough cross stratification. The second one, planar tabular cross bedding, and the third one, some ripple forms, current ripples or asymmetric ripples. So, when I am combining these parameters together, these features together, now I am getting a very distinct characterized rock bodies or facies types. So, the first one over here, it is around say 1.5 meter thick sandstone, where the grain size is starting from very coarse sand to coarse sand or maybe medium sand, having trough cross stratification. The second one is a medium grain sandstone, and there we have planar tabular cross bedding. And the third one, its thickness is around 0.5 meter, is fine grain sandstone with some ripple marks. So, now these 3 sandstone bodies, from lithology they are all sandstone, but when I am adding other parameters like the primary structure, like the grain size, they are coming up with some distinct properties, and then we can identify them as the distinct facies types. So, next comes the fourth column is with other structures and fossils, because so far in this column we have represented or we have the option for representing several features, but not all the features. In certain cases maybe we require to represent some more features which may be very distinct or very characteristic, particularly in terms of interpretation. So, maybe some fossils are present, maybe some root traces are present, maybe some trace fossils are present. So, those can be represented along this column. Also, we can take some, or we can keep some notes in the fifth column. Say for example, you have measured some paleo flow directions from the trough cross stratification, or maybe you have measured some paleo current direction from the ripple marks. So far in these 4 columns, the previous 4 columns, we do not have any scope of representing those properties, but that may be also very much important. Say for example, if it is a tidal condition, it may be tidal channel, there we may get bipolar, bimodal flow directions, so completely opposite flow directions. So that may be represented over here, and which may be very much characteristic, which may be very much helpful for interpretation purpose. So this fifth column is for representing such extra information which may be very much important, which may be very much characteristic for that particular phases. Like over here, another example is for the conglomerate, we are noting down over here, it is a polymictic conglomerate. We do not have any scope of representing that in the column. And then comes the process interpretation, where we are interpreting the processes responsible or accountable for that particular phases, and we are combining them into genetically related units together to get phases associations, and from there we are trying to interpret about the sub-environments. So this is the ideal way of representing or preparing a graphic sedimentary log. In actual practice, when you may have to deal with say 10 vertical sedimentary logs, or maybe you have to deal with 20, 30, 50 vertical sedimentary logs from one basin, there we cannot represent or we cannot use such 7 columns because it will take lot of space. So in such cases, we avoid this interpretation part from vertical sedimentary log, we keep that in the text, and also we try to club these units, these 4 columns together into 1 or 2 columns only, and there we apply more variations in terms of the patterns, in terms of the textures, in terms of colors, and then finally we add a legend where we mention very clearly, without any ambiguity, we mention that this symbol or this color is used for this particular lithology or this particular structure. So these are the standard symbols available for using in graphic sedimentary log. So if you are using this particular symbol, then without any ambiguity people will understand that this is for sandstone. If you are using this particular symbol, without any ambiguity people will understand this is for shale. Like limestone, we have this particular symbol, very common, very popular symbol, limestone. So these are standard symbols, but you can deviate from this, and you are completely open, completely flexible to use or make any new symbol. Just you have to provide the legend or the key mentioning that you are using this symbol to represent that particular feature. So when we prepare graphic sedimentary logs in this way, what we try to do is we try to understand how different phases types are occurring in vertical fashion. So we start with phases and then we combine them into phases associations within the vertical sedimentary logs. So we can understand about the phases and its vertical distribution from one vertical sedimentary log, one graphic sedimentary log. So you may have one graphical sedimentary log over here. So there we can get several phases types which are grouped into say 2 different phases associations. You may have another graphic sedimentary log over here where you are getting several phases types again, which are again divided into 2 phases associations. So individual phases types are giving us idea about the process, and the phases associations are giving us idea about the distribution of the sub environments. So this phases association can be correlated with this phases association can be correlated with this one. So maybe this is sub environment 1 and this is sub environment 2. So we are getting idea that distribution of sub environment 1 and 2 are going on in this way, laterally and vertically. So what we are doing now, based on that phases association, we try to interpret. And when we are interpreting, there comes this concept of phases model. So for interpretation of sub environments or combining the sub environments interpretation of the environment, sedimentary environment, we have to go through this phases model part. So comparison of modern and ancient examples which are already standardized, already established, already published. So with respect to them, we try to compare our model. So what we get based on that model, we get the depositional environment, interpretation of the depositional environment, and combining with processes we get idea about the depositional system, which is nothing but the 3D distribution of all the facies types which are forming within a particular depositional environment. I think you can recall the concept of depositional system that we discussed in the very beginning of this course. So, we come down to that concept, depositional systems, and that concept of depositional system leads us to the domain of sequence stratigraphy, where we deal with different elements of sequence stratigraphy like the system strat, like the sequence, parasequence, etc. So, for all this work, as you can see from this flowchart, the starting point is the facies, and that is why the concept of facies is very important in any sedimentological work and in sequence stratigraphic work. So, we have to understand the concept of facies and the concept of facies analysis. If we understand that properly, then only we can apply that for the interpretation of sedimentary environments, and interpretation of sedimentary environments will lead us to understand the distribution of depositional systems, and which in turn will lead us to construction of sequence stratigraphic model. So, these are all interconnected, starting from facies to coming up to the sequence stratigraphic model. Each and every point, each and every aspect, they are all interconnected. So, these are some of the references that I would like to suggest you for further reading. So, in this class we discussed about the concept of facies analysis and how we can apply that concept of facies analysis in the interpretation of depositional environment. Also, we will continue this discussion in our next class, and we will try to understand in more detail about this application part. Also, we have tried to learn that how graphic sedimentary logs are prepared and how they are interpreted and how they are used in the interpretation of sedimentary environments. So, thank you everybody.